We already had a couple of sessions at the beginning of January on introduction to charming, where I showed the ropes of how you write a charm, how you write an integration for a charm, and due to lack of time, I couldn't say a lot about testing, which is one of my favorite subjects. So yeah, I chose to organize another masterclass to dive a bit more into that aspect. I realized that not all of you have joined the first two sessions. I'm going to assume a little bit of knowledge when it comes to testing in general. There is a GitHub repo that I set up the last time. It contains a bunch of a few branches, and so it's a demo charm that I wrote for this masterclass. And again, it's a demo charm, right? So it is not really functional. It's not feature complete. It's not a production charm. It's don't use it in your live workloads, but it's a functional charm. And during the first two sessions, I built that charm live, so with you, and there are a few branches in that repository that you could use to follow the progress of the presentation, to follow the progress of the charm development. And so there is the main branch is essentially the empty charm repo. Part one, basic setup, is after you run charmcraft init, and you write a couple of simple things into the charm.py file. Part two, integration, is where I introduce charm libs. So recapping this, this intro to charming. Charm is deploys Nginx on machines, and it has a very simple integration that in fact does little more than that make a mock exchange between this charm and a tester charm, implementing some sort of a demo ingress relation, I called it. So the remote end submits a host and a port, and the intro to charming charm replies with here's your external URL. Now, of course, none of that really is wired in because it's a demo charm, but yeah, it gives you an idea of how that works. And part three, observability, is where I added to the charm together, Jose helped me, to add a cause agent integration, so that the charm can submit its metrics and alerts to the cause agent subordinate charm, so that you can integrate with the cause light observability stack. That, for those of you who don't know, that is my team. So that's why we added this part about observability, because we believe that writing let's say a production-ready charm means making it observable, so that whatever workload your charm is deploying can be monitored in production, which is we all know quite important. Today we are going to focus on testing. I plan to divide my attention. We have roughly 1 hour and a quarter left, and I wanted to spend a little bit of time on integration tests. Let's say, like I say, a little bit of time, because as a rule of thumb, I try to write as little integration tests as possible, because they take such a long time to develop, debug, and actually run. So part of my life goal in the charming ecosystem is make the unit test frameworks that we have so good that we only really do integration tests as a final quality gate before publishing to stable, or before publishing a charm. But all of our development should only be based on quick unit tests. Now I realize that's not always possible, but that's kind of my striving goal. So I will spend a little bit more time on unit tests. Unit tests, and in particular, I would say charm tests and scenario tests. So the distinction there is, suppose we have our charm, our charm code. Our charm code might use some functions, some methods to do generic logic. So like just generic Python code that has nothing to do with the fact that you're deployed in Juju. It has nothing to do with Kubernetes. It has nothing to do with the fact that it's a charm, right? So it's just a pure Python function. So you can test that kind of logic in a regular unit test. So you don't need harness, you don't need a scenario, you don't need any external testing library. You can do that in pure pytest or unit test or whatever your framework is. So those are, let's say, vanilla unit test or something like that. And then we have charm tests, which are, or scenario tests. And they are more about testing the life cycle of the charm, or let's say testing code, but embedded into the context of a charm, right? So a charm, we know, has a given life cycle. It receives events from Juju. It reacts to those events. It does things in the context of these events. And testing this interaction, well, that is what Harness and Scenario, the two main unit testing frameworks for charm out there right now, do. And so that's what we're going to look at. All right, so first a little bit about the setup. You will notice that this is a new style charm, as in recently Charmcraft merged the various config actions and metadata.yaml file. They squished them all into a single unified charmcraft.yaml, which contains kind of like the union of all the keys. So in charmcraft.yaml, now you have name, you have title, summary, description, you have basis, which used to be in charmcraft.yaml, you have provides, requires, config, like all of the stuff that used to be distributed in the other YAMLs. So yeah, just so you're not confused by the setup. Requirements, yeah, we only have ops in here. We use talks in most of our charms. I guess that's standard practice in Canonical, in all of our teams, to use talks for reproducible runtimes. For it's kind of like a make file, but then cooler. Some might disagree. The core environments that I'm going to be looking at today are the unit and integration. Might also touch upon static, but yeah, there's nothing really special there. It's just static type checks. This is a standard naming convention, at least in our team. We always have unit and integration, and most of our charms also have scenario, which is a slightly different battery of tests, let's say, but it's also unit tests. For the unit tests, I included ops scenario because the tests in this charm specifically are written in scenario, but I would like to show a bit the difference between writing tests with harness and scenario. Like we are in the process of, so like, okay, maybe not all of you know, but there are two unit testing libraries, frameworks out there for charms. One of them is called Harness, and one of them is called Scenario. Scenario, you install it from this ops scenario package, while Harness is built into ops. So you can do like do ops testing Harness, and it's just there. So it comes with your ops installation. You don't have to do anything special to get it. And we are now in the process of cleaning up ops scenario, so which was born as a project of mine. And we are now in the process of cleaning it up and making a 7.0 release that will be still to be determined exactly how, but we want to make it more the main way that people will write unit tests with. Thank you, Tony. With Tony's help, he's doing most of the heavy lifting for this one. So yeah, I'm still going to talk about Harness and about Scenario so that you can see the difference and the reason why. Probably, I hope I managed to convince you that why it's nicer and better to write tests with Scenario. So yeah, let's look at a test. Now this is a very, I would say, basic test, and this is written with Scenario. Let's write a unit test. So I'm going to start with Harness because yeah, that is the one that's best documented, and that is the one that is built into ops and that most people have some knowledge about. Scenario is the new joiner in the block, the new kid, the cool kid. A basic test starts like this. The Harness is, yeah, like this thing. You can think of it like a mocking wrapper. Both Harness and Scenario are mock-based instead of being patch-based. So what it means is that you know, a charm throughout its life cycle emits hook tool calls. So it can call one of these hook tools to determine whether it has leadership. Whether it has a relation, what data is in that relation, whether it can connect to a Pebble endpoint or something like this, right? So it uses hook tools to talk to the, let's call it Juju API. Harness and Scenario both act at the level of like between the charm and the hook tools. So they replace the backend that the operator framework uses to interface between the charm and the hook tools. So if you didn't know this, the operator framework is this. Essentially, it's a wrapper between the hook tools. So it presents a facade that a charm can use in a Pythonic and understandable way to interact with the hook tools. And Harness and Scenario both kind of intercept those hook tool calls, or yeah, roughly speaking, and they present back to the charm like responses as if the charm had really received a response from a hook tool. But of course, the charm is none the wiser. So long story short is with Harness and Scenario, you can mock everything that a hook tool is responsible for. So if you want to mock leadership, you can do that via Harness and Scenario natively. If you want to mock, I don't know, a curl call or a GET requests to a Google API endpoint, or if you want to mock a popen call, any of those things are outside of the domain of Harness and Scenario because they are not predictable in the same way that the hook tools are, right? So you can do anything. It's Python code, right? So you can do anything, but Harness and Scenario only are specialized for mocking the Juju interaction layer. All right, so the way you start working with harness is this. So we have our charm, which is this intro to charming mech tester charm. MC stands for master classes, but I like to call it mech tester. The main argument that you need to pass to harness is the charm type. From the charm type, harness is going to be able to like derive all the rest of the information that it needs in order to set up this mocking environment. With this, the first thing you need to do is call one of these two functions, either begin or begin with initial hooks. We saw last time that there is this massive diagram that I recently revamped, by the way, so it might look different than the last time you saw it. But this is the charm lifecycle diagram. A charm goes throughout its life in three phases: the setup phase, the operation phase, and the teardown phase. The setup phase is the sequence of events that it receives whenever it starts. So if you do Juju deploy something, the charm will receive these events in a mostly predictable sequence. With some switches. So for example, if the charm is a leader, then it will receive leader elected. If it's not a leader, it will receive leader settings changed. But for the rest, the sequence is kind of clear. And calling begin just initializes the charm, but without firing any events in it. And calling begin with initial hooks initializes the charm and fires that initial setup sequence, right? So this is something that you have to understand with harness. Harness is all about incrementally and sequentially building up the charm state. What do I mean by this? Our charm, our charm has some observers. Like what I mean is the charm does things in response to events. Now, in this case, this is a demo charm, so there is not a lot of logic in here. But what most charm code looks like is like this. We have a number of observe calls, which are like conditional callbacks. So if the event we are processing is an install event, then call this event handler. If the event we are processing is a config changed event, then call this event handler. And the underlying assumption of charms is that charms are idempotent, right? So it doesn't matter exactly what sequence of events, like what event history you have, you should be able to reach a consistent state regardless of the event you're processing right now. Harness is about simulating a sequence of events building up to a certain final state, and then you can run some assertions on your charm. So, for example, we initialize our charm and we fire the initial setup sequence. Our charm, in particular, oh wait, this is I'm looking at the tester charm. This is the yes, there is the charming MC charm. Yes, and here we have, for example, an event handler for install, right? So when we receive the install event, we are going to do these two things. We're going to install Nginx, and we're going to enable the Nginx firewall profile, which means running an UFW allow Nginx HTTP. Install Nginx means omitting a couple of apt get false to make sure that Nginx is installed. Begin with initial hooks is going to fire that event. So what we expect to see is that as soon as we initialize the charm, as soon as harness with the begin with initial hooks run, then we are going to open these two scripts, right? So the charm, this is a machine charm, so it's meant to run on Ubuntu in particular, and it just calls subprocess popen. So we need to do something about that, because otherwise running this test is going to install Nginx on my local host, which is, I mean, not that bad, but you know, it could be doing much worse things. So as I mentioned before, that is outside of the domain of harness, because harness knows nothing about subprocess calls. And I already have here a pytest fixture called popen mock, which sets up a magic mock that intercepts, that patches subprocess popen calls and replaces them with this magic mock. So all that I have to do is add this fixture here, and then hopefully this fixture is going to intercept these calls for me. And make sure that I don't accidentally install Nginx on my local host. And then we can also assert what calls have been omitted on the thing. And I already have this test somewhere else. That's not call. Okay, so let's see how this test does. No module name charms. All right, yes, that's because I forgot to add this sources root. Expected mock to have been called. Why is it not being called? Begin with initial hook. All right, of course, I'm testing the tester. Okay. Yes, I was testing the wrong charm. It's not installing any. Okay, test passed. All right, so this is a very, very simple test. So this is the test. We could call it test initial or test setup. Test setup phase, because essentially what we're doing is verifying that our charm is behaving as expected when the initial setup sequence occurs. So you have to realize that what begin with initial hooks is doing is emitting a number of events on the charm. And the charm is, by the way, this instance, right? So this is our charm. Harness initializes the charm once at the beginning of this begin with initial hooks call, because it internally calls self-begin. It sets up it instantiates the charm, and then it emits a number of events on the charm. In particular, it emits these events. If it has any storage, a number of storage attached events. If it has any relations, a number of relation created events, a leader second exchanged, leader elected, and so on. This is, I don't know, at least I found this very useful when I was learning charming, and yeah, maybe in debugging it can be helpful as well. Now, correct me, Tony, if maybe in the meantime you have added some comparable functionality into the harness natively. But there is no way to get a list of the events that have been emitted on the charm in a given time period, right?
Right.
Yes. Okay. There is this charm library that I used to like a lot. Nowadays, I don't need it anymore because it's built into the scenario. But this charm library allows you to do a cool thing. Okay, let's do this, and then let's debug this test. All right, I need to do it there. Right. Sorry. Oh, okay. This I did not expect. Needs the charm instance to be there already, so I cannot do this on begin with initial hooks. It's too bad. Okay, no, I cannot do this with begin with initial hooks because capture events, it expects the charm instance to be there, and I'm afraid if I run begin twice, yeah, it's going to complain. So I cannot do this in this test. Okay, I'll show it with another test. We can do this. Let's add a new test. Test. Let's add a relation. I don't need the pre-open mock because in like when we receive relation events, presumably. No, actually, okay. I do need the pre-open mock because what I want to do is this. Now, okay, so I want to test that. So the way that that this demo nginx charm works is that as soon as we receive a relation over this what did I call it, ingress, demo ingress endpoint, it's going to publish back a URL, like a completely mocked URL. Now, in order to test this interaction, I have to first drive the harness to the point where I can add a relation to it. Okay, add relation name, some relation. Then I need to add the unit to this relation. And okay, yeah, by the way, so notice that all of these calls, so here I'm mocking I'm telling to the harness, set up this relation. So in a way, you can, like when you're writing a harness test, you can think of each step as you running a Juju something command. So harness begin with initial hooks is you doing Juju deploy. You writing harness add relation is part of you typing Juju relate or Juju integrate toolbar. Actually, add relation unit is also part of that because when you integrate two applications, there's always some unit on the other end that shows up. And then relation data. relation D. Some remote app 0. Okay, so here we're adding a unit to this relation, and now we are going to update relation data. So in this case, we're updating the remote data bag. Okay, now here is going to be useful to do all right. Now let's look a bit into captured. This is very small, and I cannot blow it up, I'm afraid. But okay, so you're gonna have to believe me while I read you through it. In this captured variable, this is a list, and it contains 3 elements. It contains a relation created event, it contains a relation joined event, and a relation changed event. So you will realize that these 3 events are what happens when you do Juju relate, Juju integrate. Now, in Harness, you have to do this, like each one of these 3 separate calls emits one of these events. So the add relation corresponds to relation created, add relation unit corresponds to relation joined, update relation data corresponds to relation change. Yes, Stamatis.
Hi, Pietro. Based on my experience with Harness, I have seen that you can declare inside the add relation the optional arg of unit data. And if you do this, excuse me if I'm wrong, here is the question. If I do this, if I remember correctly, I can replace the 3 commands with a single one.
Yeah, that's true. Yeah,
is it exactly the same thing, or there is a difference?
So I think it's the same thing. It's well, okay, like in this case, I'm not quite doing the same thing because I'm adding relation data to the remote end. And I think if you pass application data or unit data to add relation, then you are adding data, you're writing data to the local side. So it's doing something slightly different. But yeah, but so this was also a relatively recent addition to opt. So I was not as familiar with it as could be. But so if you do app data, Michael, I'm getting to you in a second. If you do app data shell Mondo, as in hello world, then we are writing. So we are already. Yes, I think we are already unit to relation. Tony, am I right? Like app data is the local app data, or is it the remote app data?
I should know this off the top of my head. I think it's the local data, right?
Yeah, but at the same time, I see that if there is app data, then you are also adding relation units, and you are writing it to the remote app. So it's the remote one. Okay. That was
you checked faster than me.
Right. Okay. Sorry. I'll then Stamatis, you're completely right. I can replace these 3 lines by this. Yes, correct.
But with app data, not unit data.
Yes.
Oh, and here is the part that I'm a bit confused. Distinction between those 2.
Yeah, it's also adding it by default to the remote 0, right? So if you want a different unit name for whatever reason, or different unit ID. Okay. Yeah. Did that answer your question, or are you still confused about something?
What's the difference between app data and unit data in this context?
Oh, between app data and unit data. So the difference between app data and unit data is that this data, so this dictionary, is going to end up into the remote application app data bag, and foobar is going to end up in the some remote app /0 unit data bag.
Yeah. Okay. Now I get it.
So just to do a quick test, we could do assert harness charm model get relation demo ingress data. Okay, wait, let's grab relation data relation app. Right? So we expect this to show up in the remote application data, so that if the charm were to do get relation, it would get that data. Unit 0 work. Oh, it's a set. Let's offline. Yeah, let's see if this works. Yes, it works. Does this is this clear? All right. Michael, you also had a question?
Right. So I think there's something that confuses me a bit. It might be a misunderstanding on my side. So I see when you capture the events, you have 3 events. The created, joined, and changed. I expected another changed. I think it's right here.
Yes, now it's here. Yeah,
right.
Yeah, like that is because we, like, when I first ran it, we didn't have app data, or we didn't have any data. We only had one of them.
Right. Okay. Yeah. And
but indeed, that are 4 separate events.
Right. That clears that up. There's another question about the. So it's about the previous test. So here in our charm, we only had 1 handler. So what if we had multiple handlers? Would it be a best practice to assert on 1 test?
Okay, yeah, that is a good question. So you mean multiple handlers of events in the setup phase, I think.
Right, because what I understand is initial hooks will basically call all of the setup hooks.
True. So, okay, let's quickly modify our charm so that we have an on install and an on start. Both of them are in the setup phase. Then let's make a run local, I don't know, echo 1 or work. Now, when we have begin with initial hooks, we expect install to be called, which fires this popen calls, and we also emit the start event, which emits this other popen call. So let's see if the test now passes. I'm not sure if assert has calls is exhaustive, but yeah. First of all, method calls. Okay, yeah, so it shows up in the mock as we expected, and the test passes because this check is apparently not exhaustive. So we need to do echo 1, and this will still pass. Okay. Yes. So, well, to answer your question, like, is it best practice to assert on multiple event handlers? I would say no. But if you use begin with initial hooks, you have no choice, because begin with initial hooks is firing multiple events. So if you want to be more how do you say that, targeted with your harness tests as to what event handler you are testing, then you should not use begin with initial hooks. Instead, you should use begin and then manually fire the events that you want to test. Now, how does that look like? Yeah, I think you have to do that via the charm on, for example, on install, and you emit. Now, okay. We only call begin. We don't call begin with initial hooks. So the harness is not emitting the whole sequence of events of the setup phase. Instead, it's just creating the charm instance. No events are fired. So if we remove this, then this test is going to fail because we have no popen calls at all. Now let's emit the install event. And now we are going to have some calls, but not all of them because echo 1 is not in there. And we see it here. Mock does not contain call echo 1. So we remove this. And now the test passes. So if you want to, so now this is a test install event. And now we could do a test start. And instead of emitting install, we emit start. And we revert this. And the test should pass. Yeah. Is that clear?
Yeah, that clears up. Thanks a lot.
Okay. All right. Now, there are a few, well, like one, I think, something that causes some confusion every now and then and some false positives when you're writing harness tests, and that is that the charm instance is not reinitialized every event. It's every event that the harness emits on the charm, right? So as you know, probably, when like in a real charm, every event that the charm sees reinitializes the charm from scratch, right? So the init of a charm is re-executed like a fresh new Python object is created every event, with a caveat like not deferred events and not events, custom events that the charm emits on itself, right? But any Juju event reinitializes the charm. So like it starts with a fresh state in some sense. Harness does not reinitialize the charm at every hook. So that means, let's go back to the begin with initial hooks scenario. Yeah, I'm very sad about that as well. What's the first? Okay, first there's install and then there is start. So let's verify this. We receive the install event, and then, you know, you're a new charmer. You might think, oh, I'm going to do this. Some private state something. And then in start, you do you get this private state, right? So we are executing, you might think, I'm executing install and then I'm executing start as part of the setup sequence. So I'm just setting this variable in install and then I'm accessing it in start. Now, if you're a more seasoned charmer, you know, well, that's what you have to use stored state for, but this is why, because the charm gets reinitialized at every hook. But if you're running this with harness, the test will pass. And that is because harness does not reinitialize the charm. So if, like, in order to visualize, or do we still have the add relation calls? No, okay, yes, we can do that. So after we call begin with initial hooks, we have a charm instance. So charm we have a charm. Now, during add relation, as we have seen, we are emitting 4 more events. So if this were real Juju, the charm would have been reinitialized 4 times. But this is not real Juju, this is a unit test. So the charm instance attached to the harness is still the same one. That means that the charm has not been reinitialized, which leads to this kind of false positives, right? So this test passes in local, but if you try to deploy this charm, you're going to get an error because this variable, when it executes the start event, has not been defined. Any questions on this? All right. Let's remove this. Or actually, let's take it for a little bit, because what I want to talk about now is how to rewrite these tests with scenario. Okay. Now we have seen harness. Scenario is a different testing framework. It has a different philosophy, and because of that, it overcomes this difficulty of harness, and it allows you to write tests in a slightly different way. You can get it by doing pip install ops scenario, and once you do that, you get access to the scenario package. It's called ops scenario because scenario was already taken, unfortunately, by a package that nobody uses. And okay, let's test the install event in scenario. Now we still need the popen mock because just like harness, also scenario does not take care of intercepting popen calls. Then the test is already written for us in a way, like I written it before. The way you write a scenario test is, well, let's do that from scratch. Now, Tony tells me that it's best to do things namespaced, so I'm gonna get the charm like this. Then this. Okay, now this part, so the context is in a way kind of equivalent of the harness object. So you have to call it on so it's you initialize the scenario context by passing to it the charm type, not the charm instance, and context is going to take care of initializing the charm and tearing it down after each event is emitted. Now, the core difference in philosophy between scenario and harness is that scenario operates in a more declarative and I would say in a more declarative manner, and the state is immutable. So you in harness you emit events, or like you call harness methods such as begin with initial hooks and then add relation and so on in order to drive the charm and let's say the simulated Juju environment to a desired state. In scenario, you don't build up this state incrementally. Instead, you declare it all at once, right? So when you do scenario state, you are declaring the null state, I call it. So just an empty state. There are no relations, there are no containers, and so on. If you look at the state object, it's this massive data class that contains networks, containers, storage, open ports, leadership, models, secrets, resources, right? Everything that a charm can have. And when we begin with, when we have an empty state, that means that the charm has nothing. In this context, it's fine because we are testing the setup phase, right? So the charm has nothing. And in particular, this charm also has no storage or peer relations, so nothing we need to set up before install in order for the thing to be consistent. Now, okay, let's verify. Yeah. Okay, so this is the equivalent in scenario terms of the harness test that we had written before. So, yeah, the core difference is that ideally, every scenario test tests a single event. And in this case, we are testing the install event, and we are testing the install event in particular on the empty state. Now let's see a little bit how this state works. And suppose we want to test, so we want to validate that the install routine that we expect is run regardless of leadership. So we want to test that the same thing occurs whether your charm has leadership or not. If we want to do that with harness, we have to do harness set leader and pytest-operator leader false. And now this test is going to run parameterized, so it's going to run with the leadership true and false. Let's see, it passes and it passes. Now let's do the same thing with scenario, and it passes. So this means that whether the charm is leader or not, we only we always omit this sequence of calls in order to just verify that things are working as they should. We could say if self is unit its leader return, or no, not is leader return. So now the charm only installs Nginx and does the UFW thing if it's a leader. Now it's going to false. It's going to fail on false, right? So if we don't have leadership, the test fails. Next, let's test start. Now this is going to be an interesting one. Let's test start. With scenario, it looks kind of similar. So instead of having to, reach into the charm and grab the start event and evade it manually, in that scenario, it's kind of more top-level citizen. So you really work a bit more with direct events. And in this case, we expect an echo 1 call, right? Because in our start, we have we are p-opening echo 1. With leadership or without leadership, that's fine. And now it fails. So if you cannot read them, because it's too small, what it's complaining about is an attribute error. The intruder charm in my charm object has no attribute, some private state. And that is because, that is because when you run, as in the context of run with scenario, it emits this event on a fresh, brand new charm instance. And since it's a fresh, brand new charm instance, and okay, you can think of it this way. According, so far as scenario is concerned, every event is the first event ever that this charm sees. So if you didn't do anything, manually, actively to mock, patch, or modify in other way the state or the charm itself, then scenario is going to initialize the charm and not run any other events, let's say. So we have introduced earlier this bug to show the false positive in harness. Well, it does, harness gets away with it, scenario doesn't, because when we simulate the start event, we are executing on start, but on install didn't execute, and so we never set this this private state. Now it has executed earlier, right? And so it passed then, but in this other test, even if the context were the same, even if we didn't, write this in a new test, this would fail because it's running start event as if it were the first one, so it's never seen install before. Is this clear for everyone? Great. Now we have found out this bug, and now let's go for the relation relation test, which is going to be a little bit more interesting. Now, in scenario, the way, so like, okay, with the harness, what you do is you like harness at any point in time has some sort of an internal state that tells it how you have set up the model, what relations are there, whether the charm is leadership or it doesn't, maybe it has lost it. In scenario, it doesn't work this way. There is this monolithic state that you declare once and for all at the beginning of your test, hopefully. And as part of this state, you have to declare what relations are there, what data is in those relations. So it's if you're familiar with the term, it's a closed world assumption. What is not in the state is not there at all, so far as the charm knows and is concerned. So if you want the charm to be aware of something, you have to put it in state, or patch it or not, right? So, but Michael, please ask away.
Right. So so in harness, you said that it doesn't reinitialize the charm every time. Is it the same here with scenario?
No. So with scenario,
oh, it's a new
scenario.
okay.
No, like every time you run an event, it creates a completely new charm. Like there is no easy way to, okay, like in order to verify this, you have to use the context manager version with the context manager. And this test would pass. All right. So like in harness, you can grab the charm instance even after you execute an event, because the harness keeps the charm alive. But in scenario, scenario doesn't keep the charm alive for you after executing an event. So like the event really is for scenario and execution context. So it's a temporary thing that is set up, the charm is executed, and then it's torn down. And that is why if you want to access the charm to like open the black box, so to say, and I don't know, do things with the charm, say, or whatever, like make assertions on the internal state, call private methods, check stored state, like this kind of stuff. If you want to do that, and so if you want to grab the charm instance, you have to do the context manager in order to kind of to tell scenario to pause the execution, give you a handle to the charm, and then resume and fire the event so that you can go on with your simulation.
Oh, okay.
Did that answer?
Yeah.
All right, back to relations. Okay, so with scenario, we have to set up the state before the event, whatever event we want is executed. So we have to set up a demo ingress relation. And then we have to select what event we want to fire, right? Because and this is a difference with harness that makes it a little bit more technical to write tests with scenario, perhaps. Like you have to know a bit more what you want to test and how a charm works. Because in harness, you call add relation, and then all of the events that are supposed to happen. But in scenario, well, you can have a relation, but maybe you're executing a start event. Maybe you're executing an update status event. It's completely consistent to have a relation and be executing a completely unrelated, unintended event. So in scenario, you have to explicitly say what event you are running, and if you want it to be relevant to the part of the state that you are testing right now. So in this case, we are going to grab the demo ingress and created event, right? So now we are emitting the demo ingress created event. This is how you specify it in scenario. Now let's do what do we expect to be true here? So we have received a relation created event, but in this relation there is no data yet. Like the relation, you have to specify what data is in the local application data bag, in the remote application data bag, and so on. At this point in time, the relation is completely empty. So in order to simulate the same app data and unit data that we have in harness, we have to do this: remote app data, remote unit data to bar. Oh, right, yes, it's units data because it's a relation. You have to do it like this, right? So this is the remote, remote app name. App. So this is declaring the contents of some remote app 0. If we wanted to have 2 remote units in here, we could do that here. Now, if we tried to do relation, why don't we have typings? Get relation demo ingress. Now this would pass. Okay. Oh yeah, because we have bar but different. All right, because we're getting, yeah, like it's not very deterministic because it's a set, so we are grabbing the wrong unit in this case. And that passes. All right, we are a little bit short on time, so let's talk a little bit about integration tests. Like, as I mentioned, integration tests are not my favorite thing to do, not my favorite activity. I'd rather go play beach volleyball. But nonetheless, at least well, I think in every charming team, you write integration tests as somewhat more stringent quality gate because, yeah, well, here we are mocking a bunch of stuff that we want to verify that runs on a real deployed charm. You can test your charm in an integration test context, either in isolation, right? So does my charm pack and deploy? Maybe it's a charm that just does its thing on its own. But most charms, the whole point is to have integrations, so to interact with other charms in a somewhat predictable and testable manner. So like that's the other aspect of integration. So it's not just about integrating with Juju, with the cloud, with the substrate, but it's also about integrating with other charms. And in order to test the charm integrations, so like the relations with other charms, you can either test your charm with a real other charm, with a real, let's say, upstream charm that someone else wrote and maintains, or, and that is what we mostly do in our team for consistency reasons, and because it removes the dependency from the remote charms. Like we've had cases where some charms CI was broken, and in order to fix it, we had to deploy, like to merge a commit on a different repo, but the other repo was depending on the first charm for its integration tests, and they were broken. So in order to avoid this kind of dependencies, what we do in many of our integration tests, if not all, is we write tester charms. Now, tester charms are very, very minimal charms, and all that they do is present the facade of a charm that is ready to interact with your charm the way it expects. Now, this is good for testing relations. It is not enough if you are testing like real application integration. Like say you have I don't know, Kafka and a Zookeeper. Then if you want to integration test Kafka, you need to deploy the real Zookeeper, otherwise the thing is not going to work. But if, like in this case, I'm testing an ingress, so that's relatively simple. There is no application dependency. It's just the tester charm is going to publish some data to its data bags, and when you relate it to the intro to charming MC charm, and the intro to charming MC charm is going to reply with some more relation data. So in this case, it's an interaction we can really easily test with a tester charm. And I would recommend that you also do this for like the integrations for which it makes sense, because yeah, it's just much easier. Now you'll notice that I'm using in this, so this tester charm is really 40 lines. It's very minimal. All that it does is it instantiates this ingress requirer, which is an object from the demo ingress library. And what this does is publish, port, and host to application data bag of the demo ingress relation. And then what we also do is we have a common exit hook that it means that is a pattern by which on whatever event we always execute the same event handler. And you can do this in this way. In this case, what are we doing? We are setting status. That is the only thing that this charm does. It sets its own status. If we have an ingress relation, well, if we don't have any ingress relation, then we just set blocked because, well, you're supposed to relate it to a demo ingress providing charm. Otherwise, it's a tester. It has no purpose. If we do have an ingress relation, then we are going to request an ingress, so like submit to the application data bags a port and a host name. And if we do have a reply already, we are setting active status. Otherwise, we're setting waiting status. This is a very simple charm, right? So blocked until you relate, then you relate and it requests data and it sets waiting. If, like, when it receives a reply, it sets active. So that you know really at a glance whether things are the way it's supposed to be. Integration tests, and that is the third and last testing framework that we're going to see today. There are multiple out there. I know of Zaza, and that's the only other one I know. But the one that I use and my team, we all use, is pytest-operator. Pytest-operator is a PyTest plugin written on top of Python with Juju. And the main thing it does is, or let's say the main thing that I use is this ops test fixture that it exposes. It's a PyTest plugin, right? So this fixture is going to be globally available. You don't have to import it. It's just there. Via this fixture, you can do everything that you could do via a Juju CLI, right? So you can, well, not just Juju, but also Charmcraft. You can also do Charmcraft pack, and you can do Juju deploy and Juju status, show unit. Like, you can basically interact with Juju in a scripted way. That's what Python with Juju is about. The main thing that, so when you run integration tests, it's just ran through PyTest. It's nothing special about that. But Python, what pytest-operator is going to do for you first and foremost is create a model, a test model, a temporary model that it is going to destroy immediately after the test suite is done running. Because, and that is good to keep in mind, the ops test fixture is module scoped. What this means in practice is that each test module, each test file will run the tests in it sequentially and on the same Juju model. So if you have two test files, they will run on different Juju models. And if not, it's going to be the same Juju model. So that means some care needs to be exercised when like the ordering of the tests in a file matters, and if the tests are related, then keep them in one file. Like if they assume the same underlying model, keep them in one file. Otherwise, split them. That is good to keep in mind. Now, the first test that every single integration suite has is the test build and deploy, where, yeah, this is the ops test API. You can build charm, and that is essentially Charmcraft pack. You can build multiple charms. Like in this case, I am building, this is the main charm, like the intro to testing MC charm. And here I'm building the tester charm. It's an async IO based library, so you have to do everything async await. That's the way it is. And you can, yeah, like the first thing you do, like you pack a charm, you deploy it. You have to declare an application name, which is the name that the charm will be deployed at in this testing model. And one of the most useful, I think, actually one of the few very, very useful things that ops test does for you is offer this wait for idle function. Wait for idle essentially waits for the model to settle. So as you know, when you deploy things on Juju, first the machine is provisioning, then it's running the start, then it's running install, then it's running this and that, right? So like after the initial sequence, a bunch of minutes might have passed, half an hour or something. So what this wait for idle is doing is monitoring the Juju status and wait for it to stabilize. So when there is nothing happening for idle period, so let's say 20 seconds, when the model is stable for 20 seconds, then it's going to run this assertion. It's going to assert in particular that this application is in active status, and that if at any point in time while it's waiting for that, if at any point in time the application gets to blocked status, it's going to raise an error. And if the application goes into error status, in this case, I turned it off because I know that this UFW can get finicky. But you can set it to true so that the application, the test is going to fail if the application goes into errors up or raises an uncaught exception or something like that. Yeah, good to keep in mind with tester charms is that you need to keep in mind to keep the charm libs in sync, because the tester charm is going to need the same, like some of the same charm libs that your main charm needs. So you need to have them in two places in your repository. So you don't want to keep them in sync manually. So I always use some fixture like this with auto use, so you don't need to call it every time. But yeah, so this picture is to make sure that the charm libraries are copied where they should be. Now, we do the same test, build, and deploy thing about the tester charm, only there we expect the blocked status, because remember, the tester charm, when you deploy it, it goes to blocked until you relate it. Then we relate it. And at this point, we could also add a new await that the tester app goes into active. Raised on blocked false, because when we start, it is in blocked. So that makes error out. Now, ops test model integrate, that is the new lingo for relate. They changed that terminology a while ago. And yeah, this is the very basic of how you write an integration test. In order to run it, you can do docs-e integration. And especially useful to know when you're developing integration tests is this -- keep models option. Because as I mentioned, this ops test fixture is going to provision a new Juju model for you with a kind of pseudo-random name, run this whole battery of tests, and then tear it down. But in some cases, you want to keep it around to check what's wrong and to run further tests on the charms, or yeah, just debug them in some more interactive way. So that is when this -- keep models option comes in very handy, because it just allows you to keep the model around for further testing. And that is what I used in this previous run. I didn't run it live on purpose because it takes quite some time. This is a machine model, so provisioning each one of these machines took 5-10 minutes. And I didn't want you folks to wait. But so this is the final status when the tests pass and the test suite closes. The model is still around. It's called test charm 0 pick. And we have this intro charming charm, the tester reports active with ingress ready. Of course, it's a demo, so there's no ingress. But you can see the relation data in the data bags. And yeah, and this is how you write and run baseline integration test. We are out of time, or nearly out of time. I'm happy to stick around for some questions if any of you might have any.